So, good morning, students. Welcome you all on YourPedia panel. Today, we are going to discuss some of the sample questions which you may face in your upcoming exam. So, in this series, I'm going to cover 20 the most important questions from the subject of algorithm and data structure. As you know, YourPedia is the largest platform, and we already started the ISRO dedicated batch. Fine. So if you think that you want to join that batch, and this time a lot of opportunities, a lot of vacancies are in the ISRO. So if you think that you want to join this batch, you can join the batch. Regular classes are going on related to the technical subject as well as the aptitude part. Fine. So let's start with our first problem, and the problem says that in an array of n distinct positive number, what is given? We have an array of n distinct number, and numbers are positive in nature. The elements are in increasing order from the beginning until the peak element. That is the important point, keep in mind. And then start in decreasing order. That means first my array is in increasing order, then in decreasing order, and all the numbers are positive and distinct. So we need to find out what is the time complexity required to find the peak element. So first of all, we need to just take a random example, and it says that suppose that we have an array which is positive, we have positive numbers. Fine. Suppose that the numbers are like this: 10, 20, 30, 40, 60, 70, 80, 90. Suppose that these are the distinct increasing order and then decreasing order. Like I can say 85, then 75, then 65. Fine. And I need to find out the peak element. Peak element is the maximum element of this array. Fine. Now see, what is the characteristics of this, or the property of this element is the both the neighbors of this number are smaller than this number, because this is the maximum number of my array. So what you need to do, instead of, see, one method is directly scan the array, which will take order of n time. But second is apply the binary search. Suppose that you just get the 70 as your middle element. Fine. Then what you need to do, you can check that both the neighbors of 70, that is 60 and 80, one is greater, one is less. If it is greater, then go for the right hand side part. If right hand side element is greater, then go to the right subarray. In this way, you can find out the middle of next. Fine. And if left is greater, then go to the left subarray. In this way, it will take only log n time. That means you can apply binary search here. So that's why the time required to find out the peak element in this given array is order of log n. Second very important example, you need to find out or match the following algorithm and with their running complexity. So if I talk about merge sort, so merge sort is n log n, we know that. So A is what? A is 3. Now what is B? B is insertion sort, whose worst case time complexity is n square, that is 1. C is what? Binary search, and we know that binary search time complexity is log n, that is 4. And next is find minimum element in array. So finding minimum element in array take order of n time, that's why D is 2. So that is the right sequence of the match of the following points. You can see merge sort n log n time, insertion sort n square, binary search log n, and minimum element in array take order of n time. Fine. Third one, arrange the functions in ascending order of rate of growth. So my dear students, if I tell you the standard sequence of rate of growth of function, first we have the constant, then we have, I can say, log of log n, then we have a log n, then we have a root n, then we have n, then we have n log n, then we have n square, n cube, and in 2 to the power n. Fine. Now listen carefully, my dear students. We need to arrange these four functions in their rate of growth in increasing order, right? Ascending order or increasing order. So we know that 1 by n is the smallest one because as n increases, the overall function value decreases. Now, can you just tell me a relationship between first and third, root n and n log n? We know that n log n is smaller than root n. Yes, root n is smaller than n log n. Fine. And which is smaller than n factorial. So this is the sequence of rate of growth of functions. Fine. Go with the fourth question. What is the worst case running time to multiply two matrices of size n cross n? That means given two matrices. This is of size n cross n, and again this is of size n cross n. That means the resultant matrix again have a n cross n element. Yes or no? So if I talk about how to multiply two matrices, see, suppose that we have 3 cross 3 matrices. Fine, 3 cross 3 matrices. So we have to multiply these element with these and perform the addition. Fine, and we will get our first element. So in this way, we are going to get n cross n element. But we are going to find n cross n element, and to find each element we required n multiplications. That's why it will take order of n cube time. What is the right approach? N cube. Even though we have one more Stresson's example, Stresson multiplication, which is divide and conquer technique, but that will take order of n cube power 2.81. But that is not the option. That's why order of n cube is the right one. Consider the following character with the frequency. Given A's frequency is 2, B's frequency is 3, C frequency is 6, D frequency is 8, and E frequency is 10. And what is the code for character A? So it's the question from Huffman coding. So we need to draw the Huffman tree. So what are first two minimum? Two minimum is A and B. 2 plus 3. That is going to be 5. So this is over. This is over. Now next take two minimum. That is C with 6. And 5 and 6 are 11. That means now take two next to minimum. That is 8 and 10. So D is 8 and E is 10. So 8 and 10 is 18. So this is going to be 29. Yes or no? So now see what is the code. It is 0, 1, 0, 1, 1, 0, and 1. So what is the code for A? A's code is 1, 0, 0, 1, 0, 0. So A is the right answer, my dear student. A is the right answer for code A. Huffman coding is a data compression technique which says that give the maximum number of bits to a code whose frequency is less and vice versa. Next, consider the following graph. What will be the cost of minimum spanning tree? Fine, we need to find out the cost of minimum spanning tree. We have the graph A, B, C, D, E, and F. These are the vertices. Now, whenever you are trying to find out the minimum spanning tree, always just take the minimum edges, minimum weight edges. And in this graph, you see that D2 is the first minimum with the weight 2. Next minimum is D2C with the weight 3, D2F with the weight 3. Fine. So now next minimum is B2C with the weight 4. And next minimum is C2A with 5. So the total cost is 5 plus 4 plus 3 plus 2 plus 3. 5, 4, 9, 3, 12, 2, 14, 3, 17 is the right answer. Keep in mind. Fine. So it's the basic algorithm, that is a Kruskal algorithm. Always take the minimum one. Next, consider the following code. What is the running time? It is talk about the running time. Int I equal to 0, I less than an I plus plus. Can you just tell me how many number of times this for loop is going to be executed? So I start from 0 and is less than I less than n equal to n and I plus plus. It will take order of n time. We know that. Next, for j equal to 1, j is less than equal to n, j is equal to j into 2. It means j has to be start from 1, has to be reached at n, and how it is going? By a 2. 2, 4, 6, 8, 16, 32 in this way. So we know that a iterative multiplication or division gives me some log functionality. Fine. So that overall time is n log n, because the outer loop executed n times and inner loop executed log n times. So right answer is n log n. Next, the time required to merge two sorted array. That means we are going to merge two sorted array. Just take the example 10, 20, 30, and 40. We have one more 11, 21, 31, and 41 of size n each. Okay, that means of size 4 each into a new sorted array. It means of size 2n. That means we are going to take as array of size 8. And we have to make a sorted array like 10, 11, 20, 21, 30, 31, 40, 41. So what we are going to take, we have to take a pointer p here, a pointer q here, and perform the comparison. It's the merge procedure of merge sort algorithm. Fine. And we know that it will take m plus n minus 1 in the worst case number of comparisons. And you know that we have a size, both the array size is n. So which is 2n minus 1, and asymptotically it is order of n. So the right answer is A. Now, consider the abstract code to insert a node at the beginning of linked list. Okay, we are going to insert a node at the beginning of the linked list. Fine. Head is a pointer pointing to starting node of linked list. Okay, we have a head pointer which always points the starting node of linked list. New node is a pointer. New node is a pointer pointing to the newly created node. Fine. What is the correct order of the following operations? Fine. Now, before finding the answer, we need to just find out what the structure of my link is. Suppose 10, 20, 30, and 8. Fine. So we have a pointer which is pointing to the first node or the starting node of my linked list. I am going to create one more node with the data 5. And here we have a pointer that is called new node pointer. Fine. Here that means null. Now my task is to join or insert a new node at the starting of the linked list. So what type of operations I have to perform? I have to make the next of new node. This is the data part. This is the next part. So next of new node has to be head. That means new node next has to be head. And now after making this link, we have to move our head here at the starting. So what the head is? Head is now pointing to the new node. Yes or no? So A is the right answer according to that point. Fine. A is the right answer. Linked list is very important. Consider the following binary search tree. We need to find out in order predecessor of a element 50. So what is given to us? It's a binary search tree in which parent is greater than equal to left child, less than equal to right child. Fine. And we know that, see my dear students, it's a property that the in order of BST is always sorted in nature. Fine. So can we write the sorted order of the given input? The sorted order is 10, 20, 25, 30, 40, 45, 50, 60, 65, and 70. And what we are trying to find out, we are trying to find, this is the in order of my BST, and in order is always sorted. Keep in mind, oh, only for BST. I'm not talking about binary search or binary tree. I'm talking about binary search tree. So the in order predecessor of element 50 is 45. So A is the right answer. So that, and this is 60 is the in order successor of 50. Fine. So here the in order predecessor is 45. That is A is the right answer. Now consider the following statement. Binary tree is a balanced tree. So what is binary tree? A binary tree is a tree in which each node has at most two child. So can I say it is a binary tree? Yes, but it is not balanced in nature. It is left skewed or right skewed also. So the first point is false. Now the second point is binary search tree is a balanced tree. What is binary search tree? A binary search tree is a tree in which a node, a parent node, is greater than equal to left child, less than equal to right child. Let's take an example. Yes, it is binary search tree because parent is greater than equal to its left child, less than equal to its right child. But there may be a case like this. Fine. Here it is also a binary search tree, but it is not a balanced tree. That's why second is false. AVL tree is a balanced tree. Yes, my dear students, AVL is a, what is AVL? AVL tree is a, first of all, it is a BST and plus balance is balanced tree is there. That's why C is true. So which of the following statement is and are correct? C is the right answer. The time required to find the element which is neither minimum nor maximum of an array of n distinct element. Fine. We have a array. Is it sorted? No. So we need to find out a element which is neither minimum nor maximum. Let's take an example. Fine. So if you want to find out the maximum element, one possible way is you just search the maximum element by performing the linear search, which will take order of n time. Then in the similar fashion, you need to find out a element which is minimum of this array, that is order of n time again. And then you have to take one more element other than that. Fine. Which will take constant amount of time. So in this approach, it will take order of n time. Is it right? No, that is wrong. So the right way is just take the first three element, or you can say any three element. I'm not talking about first three, any three element. Then out of these three elements, because array is distinct in nature, okay? Because array is distinct in nature. That's why out of these three elements, one is the maximum one. I don't say this maximum is the maximum element of my array, but yes, there is one element who is maximum among these three. Then we have a minimum element, and one we have an element which is neither minimum nor maximum. That means you are going to write some if else conditions, okay? And through that, you will get to know what is the element which is neither minimum nor maximum. So A is the right answer. You require just 2-3 comparisons. Consider the following statements. The running time of BFS is order of V plus A, which is absolutely true. BFS, level by level traverser. BFS uses stack data structure, which is false. You know that BFS uses queue data structure and depth first search uses stack data structure. Fine. So BFS not uses stack, it uses queue data structure. And running time of both the cases is theta of V plus E. So this is true. Second one is false. So which one is true? One only. The postfix expression of the infix. So this infix is given to us and we are going to find out the postfix. So my dear students, you know that the expression is A star B plus C divide D minus E. Now, can you just tell me which are having the highest priority? So we know that star and division are the same priority. So let's go with the associativity, that is left to right. That means we are going to show the left expression first. And the post order of this one is AB whole star. Postfix, not post order, postfix. In the similar way, we are going to solve this one, that is CD division. Now, what about this plus? Because plus and minus again having the same priority with left to right associativity. So between these two, we have plus and then E minus. So which one is the right answer? A, B star, C, D division plus E minus. B is the right answer. Keep in mind, my dear students. B is the right answer while converting this infix into postfix. Next, the running time of the code. We need to find what is the time complexity of this code. See, I is less I equal to n, I less than n, I equal to I into 2. So can anybody tell me what is the running time of this algorithm? The running time of this algorithm is constant because we start from n, we have to stop at n, and next time the n value is n into 2, 2n, which is 2n is less than n? False. So only one time this statement executed or this for loop executed. What is the complexity of inner loop, J loop? So J loop executed log n time, straightforward. J1, J less than n, J equal to J into 2. So the running time of this algorithm is log n. The running time of the following recurrence. Yeah, this recurrence is very powerful recurrence to find out the kth smallest element in best case. So T of n by 2 plus n. If I solve the next one more time, n by square plus n by 2. This is the question from our standard notebook. We already solved these type of questions in our classes, regular classes. So if you want to join ISR or dedicated batch, you can join our dedicated batch. And now T of n by 2 cube plus n by 2 square plus n by 2 plus n by 2 की power 0, which give me a series after repeating the same task again and again k times. Then I just take a n common and 1 by 2 की power 0 plus 2 की power 1 plus 2 की power 2 plus in this way it returns to be almost 2, which is theta of n. So the time complexity is C. Next, consider the following graph, the cost of minimum spanning tree. Okay, we need to draw again a spanning tree. Fine. We need to draw the spanning tree of this graph. Fine. So we have A, B, C, D. You have to follow the same approach. Fine. What are the minimum edges? A to B, D to C, having weight 1. Next minimum, A to D, C to F. We have one more minimum 1, that is this one. Fine. So there is a connectivity. No, so we have 4 plus 2, 6 vertices. So it has to be 5 edges. 1, 2, 3, 4, 5. Yes. 2 plus 2, 4. 4 plus 3, 7. 7 is the right answer. Very simple problem. And you also find a lot of these type of problems, simple problems in your PYQs, fine, which we are going to solve. Already students know, which already solved in our regular classes. Very important problem. Given a hash table with a load factor of 500. So load factor is given to us, that is 500. That store 2000 elements divided by number of slots. So what is the load factor? So what are the slots? Slots are 2000 divided by 500, which is going to be 4. So none of these is the right answer. Fine. Load factor is equal to number of element divided by number of slots. Next, consider the following statement. Worst case insertion and deletion in a min heap. Yes, it will be worst case is log n. So first statement is true. Second, find the minimum element in max heap required n log n time. No, the optimal one required order of n time. So why? Because if you want to find out the maximum element in min heap or the minimum element in max heap, you have to go with the n by 2th element to the nth element. Fine. And you have an array, this one, and you need to search a element which will take order of n time. What is the time complexity of my fun? In fun, now this is again important problem. So for I equal to n, I greater than 0, I equal to I by 2. So can you just tell me how many number of times this statement executed? Log n times? Yes or no? So now next we need to check it. So when I equal to n, when I equal to n, we need to, instead of going with that, I think when I equal to n, we have j equal to 0, j less than I, j plus plus. Fine. So j is executed n times. Then I by 2. I is now n by 2. So j is executed n by 2. Next, I equal to n by 2 square. So j again executed n by 2 square time. So the series look like this: n by 2 plus again same series. So which is going to be order of n. So E is the right answer. Fine, you can solve this problem. Very simple problem. We already solved these type of questions in our regular classes, and classes are going on, technical as well as aptitude classes. Live dedicated batch is there. So if you think you have to join this ISRO dedicated batch, so you can join, contact to your PDA team, executives will reach out to you. Thank you. So in this way, we covered the 20 important problems of data structure and algorithm, and in the upcoming videos, we are regularly like posting these type of questions which are important for your ISRO exams. Thank you. Thank you so much.